Alright, boys and girls, Mr. Trutna here, Clovis High School. This is Math 2. We're going over Unit 5, Worksheet 4, and we're just going to go over the first 13 problems. Okay, so numbers 1 and numbers 2, and we're dealing with trapezoids. Notice this is talking about the properties of trapezoids. So in 1 and 2, the instructions are the given figures are trapezoids. Solve for the variable or variables in each diagram. Okay, so the first thing is that if you are told that a shape is a trapezoid, you have to assume that it is just a regular normal trapezoid and not an isosceles trapezoid. Because if you recall, we learned some special rules about an isosceles trapezoid and not we learned special rules that apply to an isosceles trapezoid, okay? All right, so what did we learn? So notice in number 1, we're talking about the angles of a trapezoid. Each one of these represent the angles. So what we learned was that the two angles that are the adjacent base angles on the top and the bottom, so these two right here, they're going to be supplementary. And the same goes for those two right there. Okay, we called those the consecutive base angles from each one of the bases. Basically, they'll run along the legs right there. So to solve for x, we're going to take the 2x angle. We're going to add it to the 136 angle, and they're going to be supplementary, so that means together they're going to add to 180. And we're going to do the same concept with these two angles right here. We're going to take the 2y plus 100 angle. We're going to add it to the 4y minus 82 angle, and those two angles are going to be supplementary, which means that they add together to equal 180, and we're going to use those equations to solve for x and solve for y. Okay, so in the first one right here, solving for x, we're subtracting 136 from each side. That gives me 2x is equal to 44. We divide both sides by 2, therefore x is equal to 22. Okay, to solve for y, a little bit more complicated, but we're just using algebra at this point, so we're going to combine the 2y with the positive 4y. That makes 6y. We're going to combine the positive 100 with the minus 82. That makes positive 18, and that equals to 180. Then we go about solving it. Still, subtract 18 from each side. That would give the new equation 6y is equal to 162. We divide both sides by 6. Therefore, y is equal to 27. Okay, so that would be number 1. Moving on to number 2, the only variable to solve for is x. And notice that x is the top base angle. So remember the rule is, in a trapezoid, the top base angle, when you combine it with the bottom base angle, so in other words, when you combine those two angles, they're going to be supplementary. So that means this angle, represented by x, if you add it to that angle, which is 88, that's going to be equal to 180. Solving for x, we subtract 88 from each side, and we get x is equal to 92. Okay, so that's how you would go about solving number 1 and number 2. Numbers 3 through 7, the instructions are find x and the length of the given segment. So you notice in number 3, the first thing we're going to do is we're going to find x, and then we're going to find segment GH. Okay, so here's the rule that we're going to use here, and we're going to use the mid-segment rule. Okay, so remember this line segment right here, which is represented by 2x, is the mid-segment, and the rule is that the mid-segment is equal to the sum of the two bases. So 10 is a base, and 3x minus 4 is a base. Remember, the bases are the parallel sides of a trapezoid. So if we take those two bases and we add them up, then and then we divide that by 2, that's going to be equal to the mid-segment. So the mid-segment, 2x, is equal to the sum of the two bases, 10 plus 3x minus 4 divided by 2. Okay, and then we solve this equation out for x. So we're going to get 2x is equal to, and now I'm going to combine the 10 and the minus 4, so that makes 3x plus 6 divided by 2. Okay, now, when I'm at this point in the problem, you'll see in various problems that I do, if 2 divides into both of these numbers evenly, the best option is to divide it. Okay, and then solve. But if 2 doesn't divide into both of these numbers, and you can see 2 does not divide into 3 evenly, then your best option is to simply just multiply each side of the equation by 2. Okay, 2 times 2x gives me 4x. So when I work this out, I get 4x is equal to, and then these 2's would cancel out. 3x plus 6, okay? That is always an option. We'll do another problem where you could actually divide by 2 instead of multiplying by 2. Okay, continuing to solve, I subtract 3x's from each side. That gives me the 3x's cancel out, x is equal to 6. Okay, now I'm going to find the value of GH. So to find the value of GH, GH is represented by the expression right here, 2x. And I'm going to substitute 6 in the place of x. So that's going to make this 2 times 6. So GH is going to be 12. All right, so that would be number 3. Number 4 now. So we're using the same idea as we did. As a matter of fact, in all these problems, we're using the midsegment property in order to solve for x in each problem. So in number 4, we're solving for x, and then we're going to find the value of FE. So we have a midsegment right here, which is represented by 4x plus 1. And then we have 2 bases. We have this base, which is represented by 10. This base, which is represented by 6x minus 2. So the rule is the midsegment, 4x plus 1, is equal to the sum of the 2 bases. So we're going to take 6x minus 2. We're going to add it to 10, and then we're going to divide that by 2. So you add the 2 bases up, you divide it by 2, that's equal to the midsegment. Okay, simplifying this out, we would get 4x plus 1 is equal to, then we're going to combine the minus 2 and the plus 8 to make the numerator 6x plus 8 divided by 2. Okay, now this particular problem would be the type of problem that I was saying about before, where you could actually divide by 2 because 2 divides into 6 and it also divides into 8. So it would be a good idea just to divide by 2. So that would make your equation 4x plus 1 is equal to 3x plus 4. Okay, so remember when you divide by 2 though, you got to divide both pieces by 2 right there. Okay, now I would solve. So I would subtract 3, I would continue to solve, subtract 3x's from both sides. That would cancel out the 3x's. That would make my equation x plus 1 is equal to 4. Subtracting 1 from each side, we get x is equal to 3. Okay, so then we want to find the length of FE. So we go over here, notice FE is this bottom base. So FE is represented by the expression 6 times x minus 2. We're going to substitute 3 in the place of x to make this 6 times 3, which is 18, minus 2, which is 16. So F to E would be equal to 16. Okay, so that would be how we do number 4. Number 5, same idea. Notice we have a midsegment, which is G to H, which is 3x, which is represented by 3x minus 6. So, and then we have 2 bases. We have this bottom base, which is represented by 25, and we have this top base, which is represented by 2x minus 1. So the midsegment property says the midsegment, which is 3x minus 6, is equal to the 2 bases added up. So 2x minus 1 added with 25 divided by 2. Okay? Why do we divide by 2, by the way, if you were wondering? Because the midsegment's in the middle. If you want to find the middle between 2 things, you always just add them up and divide by 2. Okay, so now I'm going to solve this. So I'm going to take the numerator. I'm going to combine the minus 1 with the plus 25 to make my new equation, 3x minus 6 is equal to 2x plus 24 divided by 2. Okay, so now if you notice, this 2 divides into 2. It also divides into 24, so it's a good idea to divide both of those by 2. That would make my equation 3x minus 6 is equal to 2x divided by 2 is just x, plus 24 divided by 2 is 12. And then I continue to solve, subtracting x from both sides of the equation. Canceling out the x's, my new equation becomes 2x minus 6 equals 12. Next, I would add 6 to both sides of the equation. Canceling out the 6's, my new equation would become 2x is equal to 18. Then I would divide both sides by 2. Therefore, x is equal to 9. Okay, so that's one of my answers. The next thing I want to do is I want to find the length of C to D. Okay, so C to D is this top base up here, and it's represented by the expression 2x minus 1. We're going to substitute 9 in the place of x, so that would make C to D 2 times 9, which is 18, minus 1, so that's equal to 17. So there's your length of C to D, and there's your value of x for number 5. Okay, moving on to number 6, more practice on this. So you notice in number 6, we got a little bit more complicated because we're going to have a decimal involved. Whoop-de-doo, we still have a midsegment. A midsegment, remember, is a segment that runs right in the middle of a trapezoid. How do we know it's in the middle? Well, because T is a midpoint, as denoted by these congruent marks, as is U, as denoted by those congruent marks. So we're going to take the two bases, which are 4x and which are 8x plus 3, and we're going to add them up and divide them by 2 to make it equal to the midsegment. So 4x plus 7.5, which is your midsegment, is going to be equal to the 8x plus 3 base added to the 4x plus base, and which way you add them doesn't matter, divided by 2. Okay? To simplify this, I'm going to combine the 4x and the 8x to make 12x. So my new equation would be 4x plus 7.5 is equal to 12x plus 3 divided by 2. Now this is the type of problem where you have to say to yourself, okay, is it such a good idea for me to divide by 2? I would say no, because although 2 divides into 12 evenly, 2 does not divide into 3. So if you can't divide both of the numerals by 2, go ahead and just multiply both sides of the equation by 2. Excuse me. So distributing the 2, I get 2 times 4x, that's 8x, plus 2 times 7.5 is 15. That worked out groovy because I got rid of the decimal. That is equal to, and those 2's cancel out, so I get 12x plus 3. Okay, now if you notice, I'm going to subtract 8x's from both sides because 12x is more than 8x, so I get rid of the smaller side x's. When I do that, I get a new equation. I'm going to bring it over here. I have a 15 is equal to 12x minus 8x is 4x plus 3. Continuing to solve, let's subtract 3 from both sides. That would cancel out those 3's, and my new equation would be 12 is equal to 4x. I divide both sides by 4, and I get 3 is equal to x. So there's my answer for x. Now I want to find the length of T to U. So T to U is represented by the expression 4 times x plus 7.5. So that's what T to U is represented by. But now that I know x is 3, I substitute a 3 in here. So I would get 4 times 3, that's 12, plus 7.5, so I get 19.5 for T to U. Okay, all right, number 7, same idea. I'm using the idea of the midsegment, but in number 7, whoever wrote this problem was trying to confuse you students, because if you notice, they turned the trapezoid around. So this trapezoid is juxtaposed, it's rotated differently than the previous 3. Okay, big deal. So notice we still have a midsegment right there, that's 22. So we're going to use the midsegment rule, which says that the midsegment, which is 22, is going to be equal to the sum of the two bases. So I'm going to take these two bases and I'm going to add them up and then divide by 2. So I'm going to take the x plus 3 base, I'm going to add it to the 4x plus 1 base, and then I'm going to divide by 2, and that would be equal to the midsegment, which is 22. Okay? Combining like terms on the numerator for the right side of the equation, I have an x and a 4x, so that gives me a 5x. And then I have a positive 3 and a positive 1, which gives me positive 4. Okay, so now I'm dividing by 2. Should I divide by 2? No, because 2 does not go in the 5. So remember, your other option is multiply both sides of the equation by 2. That would eliminate those 2's. 2 times 22 is 44. That is equal to 5x plus 4, and I continue to solve. Subtract 4 from both sides. That gives me 40 is equal to 5x. I divide both sides by 5, therefore x is equal to 8. Okay, then I want to find the length of w to z. So w to z is represented by the expression x plus 3. We just found out that x is equal to 8, so I'm going to substitute 8 in the place of x. 8 plus 3 is 11. Okay, so that would be number 7. Okay, flipping the page over, we're going to do, remember, we're doing 1 to 13. That was the assignment. Okay, so number 8. Number 8, now we're going to start talking about isosceles trapezoids. So number 8 says, what is true about an isosceles trapezoid that is not necessarily true about all trapezoids? And there were 3 things. So the first thing is, an isosceles trapezoid will have 2 equal legs. Okay? The second thing is that the base angles, the top base angles are congruent. So the 2 base angles on the top would be congruent, and the bottom base angles are going to be congruent. Okay, are congruent. Base angles are congruent. Okay, so what does that mean? And we'll see a picture of it when we do numbers 9, 10, 11, 12. Okay, it means that the 2 angles on the top would be congruent, and the 2 angles on the bottom are going to be congruent to each other. And the third thing that is true about an isosceles trapezoid, but not necessarily true about all trapezoids, is the diagonals are congruent to each other. Okay, so that's the 3. These 3 properties are exclusive just for isosceles trapezoids. So number 9 and 10, find the measures of the numbered angles in each isosceles trapezoid. Okay, notice we are given this top left base angle is 58, so that would make angle 1 58. Okay, we are using this property right here which says the top base angles are congruent. Okay, so these 2 angles right here would be 58, and then to find angle 3 or to find angle 2, we're going to do it the same way. What we would do is, remember, the consecutive base angles on the top and the bottom are supplementary. So if we wanted to find angle 3, we would subtract 58 from 180. Okay, and that would turn out to be 122. So angle 3 would be 122. And then, notice it says here, the bottom base angles are congruent. So if this angle is 122, that means angle 2 has to be 122 degrees as well. Okay? Number 10, same idea. Notice it's an isosceles trapezoid. How do we know number 10 is an isosceles trapezoid? Well, it's indicated by these congruent marks. Remember, whenever you see the word isosceles in front of a shape, that isosceles means that we're going to have 2 equal legs. And the legs are the non-parallel sides, okay? So that angle is 109, so the angle here would be 109 as well. And one way that you could look at this problem is you could turn the trapezoid. Let me get it in so you can see it. You can look at it this way right here. Okay, so the 2 top base angles are the same. So angle 1 would have to be 109 degrees. Okay, and then angle 2 and angle 3 are going to be equal to each other, and to find angle 3, you would just take 180, subtract it from 109, so that would be 71. So that means angle 2 and angle 3 would both be 71 degrees. Okay, number 11, find the value of n in each isosceles triangle. Whoops, there we go. Find the value of n in each isosceles trapezoid. Okay, so we have a trapezoid as indicated by 1 pair of parallel sides, and we know it's isosceles because these 2 legs are equal. Okay, so remember the rule is the top base angles are congruent, so those 2 angles are going to be congruent, and those bottom base angles are congruent. So that angle and that angle are congruent. So my equation to solve for n would be 3n is equal to 1/17. Divide both sides by 3. and those 3's would cancel out and would be equal to 39. Okay, number 12, same idea. We have an isosceles trapezoid again, as indicated by the 2 congruent marks, so that means those 2 angles are equal to each other. The bottom base angles are equal. Okay, so we would take that angle, 48, set it equal to that angle, 5n plus 3, and I'm going to write it opposite of what I said. 5n plus 3 is equal to 48, and we're going to solve that out for n by subtracting 3 from each side. 3's would cancel. New equation, 5n is equal to 45. Divide both sides by 5, n is equal to 9. Okay, last problem that was assigned to you on this worksheet, number 13. Number 13 says find the value or the values of the variables in each isosceles trapezoid. So we know the shape is an isosceles trapezoid. So that means the 2 legs are congruent as indicated by those congruent tick marks. And number 13, we're finding x. Okay, so if you notice, this part right here, this x minus 1, that was just put there to distract you. So you don't, that x minus 1 is not going to help you solve for x. So what do we know? Well, we know these 2 legs are equal. So we know that the 3x minus 3 leg has to be equal to the x plus 5 leg. Remember, if a trapezoid is isosceles, it means the 2 legs, in other words, the 2 non-parallel sides are equal. And then I would solve this out. So I would subtract x from both sides, and I'm going to do the old Texas 2-step. I'm also going to add 3 to both sides to shorten my steps up. So those 3's would cancel, those x's would cancel. And then I would get an equation of 3x minus x, which is 2x. That would be equal to 5 plus 3, which is 8. Then I would divide both sides by 2. X is equal to 4. There we go. Enjoy. Come with questions to class.